our approach is, hey, we think machine learning is completely transformational. It's the new kind of revolution in technology. It is going to change absolutely everything. It already has done and already is doing.
I'm Misha da Vinci. This is Innoveum, a podcast about people, technology, and how we can build a better future together. Let's dive in. Ben, hey.
Hey, how's it going?
Good, how are you?
Not too bad, thanks. Not too bad.
Okay, let me introduce you. Ben Fielding is co-founder of Gensyn, the decentralized machine learning compute protocol. He was previously co-founder of a data privacy startup. He has a PhD in neural architecture search for deep learning and computer vision. So Ben, hi, thanks for coming on.
Thanks for having me. Great to be here.
I'm so excited to get to know a little bit more about you and what you're building at Gensyn. And more than that, how you're, playing a foundational role in building a new future for humanity. But before we get into all of that good technical side of things, let's get to know you a little bit. In this little part of the ecosystem, this community that I'm building at Innoveum, we're all about the human side of things. So it's important for us to take some time to do that. So tell us about you and how, as a child growing up, did you care about this stuff? Did you imagine one day you'd become a founder of some transformational technology that maybe changed the lives of billions of people?
Good question. Yeah, I think probably two themes that are relevant here that I can kind of think of off the cuff. One, I've always had essentially a desire to have the freedom to determine where I put my time and what I do with my kind of life, basically, which like presented itself in I think, as is common to a lot of people, frustrations in school that like I didn't want to just sit there and listen to whatever was being kind of told to me. I wanted to be doing things that I thought were the right thing to do in a certain moment. And at different points in schooling, that was maybe useful, maybe significantly less useful.
So give an example of how you were rebellious and broke the rules or didn't go along with authority. What did you do?
So I think I have always struggled with just generally, or in the past, with maths education or math education, I guess, for the US audience. In that I didn't understand a lot of the reason I was being taught something, which meant that like it was very difficult for me to actually kind of engage with that, because I thought I don't see why I'm spending my time into this. And at different points, I think this is highly dependent on maths education itself. I think you can do it in a way where you do engage people and you explain the kind of reasoning behind things, rather than just hand them an equation and say, hey, you apply this to this, and then like you get something out of it. You don't need to know why. But that kind of approach of like, do this here and then this happens and you don't need to know why, just didn't work for me, because I was like, I need to know why. Otherwise, my brain isn't going to actually engage. I'm just going to be like checked out here, which was a kind of a theme for a bunch of that. But through that was one of those things where later on, I realized I did know why. A lot of machine learning obviously requires enormous amounts of linear algebra, etc. Yeah. And at that point, I was like, okay, I get it now. Right, I'm gonna have to go back and kind of learn that stuff that I didn't learn by rote in the past. So yeah, that's probably the cleanest example of that, where until I saw a reason for myself to do it, it was unlikely to happen for me. And then leaning into that, I say, well, going forwards in my professional career, I'm going to want to index to that kind of as a power itself, and say that I'm going to apply myself to things that I think are like worth doing, basically, rather than maybe sitting in a job where I can do the actions and I can get paid, but like I don't really see a point in doing the actions. And it was very clear to me. I did a year in industry during my degree, so a sandwich degree, where in the third year you go out and work basically like an internship. You do an entire year.
What were you studying in this
degree? So I
degree?
studied computer science undergrad. And then, in my third year, I went and worked as a database administrator, working on Oracle databases for about 14 months. which was fascinating at first because like I'd done some database stuff. I found them fascinating from a technical perspective, but very quickly became something that I'd covered all the sort of technical details. I'd learned all of the things that I needed to learn to do the job. And then once it had moved into, okay, you just do these actions each week, and that's kind of the job, it became pretty stale to me.
Yeah, boring.
Um,
Yeah.
yeah. And so that was when I realized, hey, I'm going to need to keep this like pace of learning and kind of seeing the reason I apply myself to this going like perpetually. Otherwise, I'm just going to get sick of whatever I do. There were two paths to do that. The one I saw when I was doing that database administrator role was the startup path. The company I was in was a small company. A lot of the people within it were kind of in the startup world. So got introduced to Hacker News and like Y Combinator as a concept and sort of started moving into that world a little bit. But then I went back to university and realized the second path that could take advantage of that approach, which is academia. And so never considered a PhD, didn't know anyone who'd done one. It was like this kind of completely unknown world to me. But one of my professors just kind of had an open call in one of the lectures. Is anyone thinking about this? I said, well, no, but like, I want to find out more, and realized that actually that represented a potential path to do the same, to do directed
What was your
research.
PhD in neural architecture search for deep learning and computer vision? So you were studying that. Okay,
Yeah.
so you were going to go on this academic path, and yet here you are, founding this
Yes.
startup. How did that happen?
A similar kind of realization to the year in industry where I I started out my PhD with a pretty open kind of like remit that we it was industry funded by industry in part, and so there was a sort of there was a requirement or a specification that we put together for the industrial applications, and then from there I obviously did self-directed research,
Hmm.
and as part of that I moved away from that specific industry application and into some areas of theory that I thought were particularly interesting and like needed approaches. And that was the neural architecture search. So it was at the time when machine learning was it had broken out of being a purely mathematical thing. So AlexNet had come out a few years before, proven that you could actually do these networks at some kind of scale now. They were actually applicable in the real world with parallelized hardware. And so that sort of wave was happening. The department I was in was computer vision, and it was still sort of moving from statistical techniques to deep learning. There was obviously at the time, I think every computer science department went through this, where you had some people who said, no, we're never going to give up our like histograms of gradients and texture filters and things. And some other people were like, yes, let's lean into this new technology. My department sort of flicked back and forth between the two, but ultimately definitely went the deep learning route. But what we all realized at that time, I think, was the world quickly went from handcrafting a neural network architecture is novel and you can make a new one and it's way more performant and this is interesting to it's actually just a search problem. We can keep doing that with people and proposing it as novel research, but actually just combining blocks in a different way isn't necessarily novel for a
Novel.
conference or a journal anymore.
Hmm.
It's just a search problem. So that was how I treated it. Used evolutionary algorithms because I'm just a kind of big believer, frankly, in like swarm methods. I think they're really interesting methods. They're effective. There's some nice analogies to like wisdom of the crowds within how humans learn and establish truth and things like that. So use those to search architectures. And then in doing that, I think I realized the sort of realities of academia and the publish or perish paradigms, the idea that I think the vast majority of high impact research happens at a very small number of institutions, which are very hard to break into depending on where you've started.
Yeah.
It was clear to me that because I fell into academia late, I wasn't on the kind of preordained path to do that. I could probably have made my way to those places, but it would have been slow and kind of hard as a grind. And it represented a ceiling or a barrier to me in doing that. And I wanted to have the highest impact I could. So I realized, hey, I can try and attach myself to the academic path and sort of like take advantage of that, but it's going to be slow. Or I can go out and just see what I can do if I take all the blockers off and just put it versus me just out there.
Was that
And so that
scary?
appealed to me.
Was that,
Um,
were you like, oh my God, I'm going to actually jump into the arena and this could totally, like, I could fail hard.
Not really, to be honest, because I think through a lot of stuff, like I think my relationship with failure is probably reasonably healthy.
Mm,
As I described in schooling, like there were times when I do like very well, but there were times when I wouldn't do particularly well because I didn't engage. But to me, I don't know, that didn't get too deep into me because I wasn't actually that bothered about it. So I think that when it came to this, it was
yeah.
just the same thing where I was like, well, actually, I've not been like preordained with any of these, like you're this successful person and like if you fail then it's a failure. It was more
Yeah,
like, well, everything's been like a little iteration on the top, so there's nowhere to fall really, so
yeah,
it doesn't really matter.
yeah,
um, which was reasonably nice.
yeah,
And at the same time, I'd already made multiple choices, which, if you put logic on top of them, led
yeah,
to lower outcomes statistically anyway. I think doing a PhD in the UK actually leads to like statistically lower overall financial outcomes for most individuals. So it's like you've already made the choices that go down a path
yeah,
which isn't
yeah.
necessarily like up in light success. So it doesn't really matter. Just
Got it.
index to the thing that I get energy from was the like compounding effect that I was going for.
I love it. I love it. I love it. Love it. Love it. So brilliant. Okay, so I really want to come back and talk about that whole founder thing, but we got to talk about Jensen. So, okay, so you're going to break this down for us. So let me just a little sort of a frame on this. The people who are going to be listening to this, my audience, are people who are like normal people. They're not tech brains. They're not nerdies. They're smart, super, super smart. Maybe experts in their fields, but they're not techies. So the job is always translating.
Mhm.
Okay, so Jensen is a machine learning compute protocol or a network for machine intelligence. So let's just start with
Sure.
that and just break down those core concepts. Well, we kind of know what machine learning is, but what is a compute for machine learning protocol? I mean, I know that is the intersect of
Yep.
crypto and AI, but what is that for normal people?
Sure. So in kind of, I guess in the simplest principle, it is, and we can get into the other resources and how this fleshes out in the second part that you
Yeah.
mentioned, but specifically on compute, there are certain resources that are required for machine learning to just happen. So for machine intelligence to do something, to take actions, it needs certain things to go in at the bottom before it can do that. Compute is the easily the largest and most kind of obvious one. It basically says if you want machine learning operations, so these mathematical operations that allow us to make decisions entirely programmatically, have to execute somewhere. There are a lot of floating point operations within matrices. Those need to happen on a processor. So, like some processor somewhere in the world has to execute these mathematical operations in order for
Mm-hmm.
machine learning to exist. The current state of the world is that we are resource constrained on compute. So there's more machine learning that people want to do than there is compute in the world, which means that we have this kind of like supply and demand mismatch where we have to try and allocate the supply of compute to the larger kind of demand. And that creates like a financial market over it.
Right.
But that financial market right now is very siloed. And there's various benefits for it being siloed to companies who already have access. So you can say if you're building a machine learning company, you're going out into the world and you're saying, hey, using machine learning, we can create this kind of profit-making benefit somewhere. Somebody wants to pay us for the machine learning that we execute because we're doing something new and kind of novel for them, and it provides them value.
Yeah.
The problem is when a company does that, the company then has to think about defensibility. And if you think about defensibility in a purely kind of financially rational way, that company is incentivized to do the actions that lead to the greatest defensibility with the lowest cost to themselves, essentially.
Okay.
Um, the lowest cost way to do defensibility as a company in that situation is basically to hoard the compute and stop other people from having access to it, because then they can't do the thing. They have to have compute to do it. If you have more compute and you keep like control of it, they just can't do it. So they're gonna have to find it somewhere else. And so this isn't saying that anyone's being malicious or anything. It's looking at this whole system and saying, hey, the incentive in the system is for somebody to do that, which means it will happen because it's the most logical
Yeah.
path. So we look at that and we say that is net bad overall for the world because it leads to lower competition at the actual machine learning level. Because what we'd like, I think everybody in the world kind of globally optimally would like the best machine learning model to be used in every situation. Similar to how we want to buy the best product we can for the lowest price we can whenever we go out and kind of purchase something from a company. And we assume that we can do that because of competition. So we say, hey, there's like 5 different products here. And because they're competing with each other, I get like the most optimal choice. If there's a monopoly, I don't actually get the most optimal choice. So there's an ability to create that monopoly using resources, which is actually worse for the world than if you unlock unlock those resources in some way, separate them from the core business and say to the businesses, your core business is competing on the machine learning you're doing. So you're going to have the best machine learning. And that pushes companies down that route of saying, we're going to do the best machine learning, we're going to beat you. And then the kind of world moves up like that, rather than saying a company manages to amass compute and then they can kind of take a back seat on machine learning because it's like, well, no one can compete anyway. So we'll just do what's good enough. We'll sell that and that's good. So our approach is, hey, we think machine learning is completely transformational. It's the new kind of revolution in technology. It is going to change absolutely everything. It already has done and already is doing. Everyone in the world wants that to be applied the most effectively, I assume. In order to do that, we want to make a separation between the base resources that shouldn't be captured, in our opinion, by companies and used defensively, make those completely open and like not free, but kind of free in the sense of anyone can access them, and
Accessible,
then
yeah.
force companies to compete at the higher level.
Yeah.
And so the kind of intuition we have there is we look at the internet. This happened with communication with the internet, where we went down the kind of internet protocol wars. We skip about a 10-year period where there was lots of people trying to capture the protocol itself. In the end, we came out with like TCP/IP, the IP stack, which is an open standard that everyone can use. And that means that there aren't silos of companies. Well, there still are, but there isn't a dominant silo of companies which say, this is how you have to communicate. We control it. Everything has to go through us, even though many have tried in the past. And so we look at that and we say, well, the resource back then for the internet, which was transformational, was communication. We had to have a completely open way of communicating between devices. The new era is the resource now is computation. We should have the same thing. So let's just build that standardized communication kind of layer, but for computation. The problem is there's different dynamics with computation. It's weirdly expensive. You can't just sort of say, well, costs will just average out. Telecoms companies can come in and like do it in aggregate. That can't exist when you're saying it might be like $3 per hour to execute something on someone's compute device. Like that's a huge amount of money that needs to be more granularly paid. Otherwise, there's going to be debts all over the place. So you have to bake in some of the payments into the protocol itself. Another reason is the internet emerged in a good way organically, but it could have gone in other directions. We can't trust that it'll necessarily emerge organically, openly this time. So we can learn from what happened last time and say, okay, there's bits of that probably if we redesign those protocols, we'd probably design into the protocol. And so payments is a great example of that as well. There's loads more I could get into on the crypto side.
Yeah.
Establishing trust is a huge piece. You cannot have what we've just described without solving the trust problem. That's super deep. I don't know how deep you want to go into that rabbit hole.
Okay. So we talk about compute and the importance of compute and why in this new world that's being built, compute is something that everybody's going to need everywhere all the time. Like that's what you were basically just saying. And I'd love to dive into that, sort of your vision a little further on, your vision of like, say, 2030. What's going on and how are we interacting with machines and how is machine learning critical in all of the things that we're doing? So let's just pin that for a second. So we looked at the machine learning side and we looked at the protocol side, which is the crypto decentralization side and how these two work together to create something that hitherto has never been possible in humanity. And what it means moving forward into the future, you're building the infrastructure of systems that allow humans to do very different things and function in very different ways, and hopefully far more effective ways, and ways that allow humans and human creativity to flourish, which is sort of my agenda in all of this. Okay, so back to Gensyn. So you founded Gensyn in 2021. You've had like 3 rounds of funding. It's beautifully funded. You have a great co-founder, Harry Grieve. So as you're founding Gensyn, like what was that thrust? Like you're thinking, there's this big, massive, horrible problem that exists with compute, access to compute. Let's go solve it. Tell us about how you thought about that and then how you tackled that and then how it's going.
Sure. So we actually, when I met Harry, we actually originally started out doing very large scale, so global machine learning, but over data silos rather than compute in kind of silos. And so the intuition behind that was my previous startup was in privacy. I knew a lot about privacy regulations and how privacy was doing a similar thing in terms of creating barriers for companies predominantly, but also in a bad state for just individuals. Like we were giving up all of our data to businesses and then they
Yeah.
were doing whatever they want with it, etc. So there were various problems in that. I tried to solve the latter one in my previous startup. Won't go into that, but kind of moved into Gensyn where we said, there's similar issues within enterprise finance around privacy regulations where people can't move data sets around within businesses. Typically, like tier one banks, for example, you've got data on customers in different jurisdictions. You can't move that data between jurisdictions, but there are certain operations you as a bank need to be able to do in order to kind of learn about what's going on with your customers, and they couldn't do that. And so we looked at that and said, well, you can split these models over all of these different bits of data, and you can combine and get results in one place, and that helps you kind of solve that problem because you're not like violating privacy, you're not moving any data, you're just asking the question you need to ask and only getting that answer. So it's a much better solution basically for everyone. It's better for the individual because your data is not being sent all over the place, but it's better for the bank because they can actually answer the questions they have without kind of violating any regulations or like individual privacy or anything like that. So we originally started out there. TLDR, that's a viable problem, but banks are very slow. The technology itself is hard to apply and it needs to be proven in a white box way. And that is just going to take a long time before a bank can actually adopt this in anger. And we saw that as a company where we realized, hey, the timelines on this are crazy long. That's fine. We were happy to go and push through that. But at the same time, we were very aware of the compute problem individually, both from machine learning. We both experienced it. Machine learning was clearly moving out of research and into applied domain heavily. And then like you could see that the resource constraint was increasing. Everyone in our networks were talking about compute. And we just realized, hey, we're splitting these models all over the world. We're kind of sending bits around. We're getting results back in one place. That actually solves the compute problem. And that's a much more kind of immediate problem, which we actually think is a larger blocker to the world. So let's like dive in and kind of look at that. So this was probably 9 months after we started, after the first round of funding, where we realized actually, hey, this same technology we're describing is applicable here more immediately and kind of more clearly, but you have to solve a problem. And that problem we very quickly realized was trust. So you say, we can split models up and we can put them over different compute devices. Amazing. That increases the supply of compute available to the person who has the model, but they have to trust each compute device. Otherwise, that person might just lie to them and say, hey, I trained your model. You can't actually like check my work because you don't have the hardware to train it yourself. So you just have to trust me that I did it. Here's the results back. How do you solve that? We went down a very deep research rabbit hole. We weren't crypto people. We didn't know anything about crypto really. In that rabbit hole, we were reading verifiable computation research and got to the kind of blocker point of if two people don't trust each other in a computation, the only way for them to establish trust is to put trust into a third party. They have to have a trusted third party to mediate that dispute. There isn't a way around that. And then in some of the papers found that people were using the consensus of a crowd as a trusted third party. And that was the light bulb moment for us where we said, oh, that's the value here of crypto as a space, as a technology at the low level. It lets you establish
This is the
trust.
only value. You're like, prior to this, you're like, crypto, whoa, no.
I mean,
now you're like, crypto. Finally, crypto works.
I mean, it kind of was. I mean, obviously, we as technical people, we'd intersected with it. Like
Exactly.
I'd mined various things,
This is
but
the
it'd
real
been this
value of
thing.
crypto. This is the real.
Yeah.
Agree.
I mean,
I agree.
interestingly, and this is something we think about a lot. Interestingly, once we'd gone through that, we
Mm.
realized that philosophically we were heavily aligned with the crypto space. But we'd never gone past that barrier before of like, okay, yeah, it's money and like, oh, it's digital and all
Yeah.
of this, but like, I don't really get why it's like interesting. And I'd read the Bitcoin white paper and stuff, but
Yeah.
it hadn't kind of clicked for me the applicability of it beyond just the financial use case, which I still then saw as kind of like almost like a toy thing where I was like, that's interesting,
Yeah.
but I don't see why it goes wider. And then this was when I saw why it goes wider because I was like, the general purpose use case of establishing trust programmatically is insanely good. That's amazing.
It applies to every single sort of human marketplace interaction across every industry, across the globe. It
Yeah.
allows, again, possibilities that we could not previously imagined, and it takes control and power from small siloed places or hierarchical structures and distributes it across the world, allowing
Yeah,
humans to flourish in an entirely different way, which is what I get super excited about. And people are talking about, oh,
totally.
money go up, and I'm like, guys, you're missing the point entirely. This thing is way cooler than that because your money can go up and it'll go down and you'll be miserable. But how about something that gives you actual power, like for the first time ever? Like, come
Yeah,
on. And at a micro level, as an individual, and at a firm level, at a community level, at every level, like this is like the greatest thing ever. Okay, so
yeah.
yay. Okay, so okay,
I think
so
just on that
go.
actually. So all of those like downstream kind of things it enables were things that I'd heard people say before, but maybe this goes back to the start of this discussion where it was like I hear people say it, but I don't fully understand why, which means that I'm just like I disengage with it because I'm like I don't get why we can do that now and why we couldn't before. And then this moment for me was that like key piece where it was like all of that can exist and I get why it can exist now once
Yeah.
we've got that piece of establishing like trust. And I just hadn't but somehow I hadn't kind of like really like gone deep technically on it and said, okay, that's how that works. I get the trust piece, right? All that this entire world can now exist on top of it. But once I had a reason to need that piece, then I
Hmm.
went in, learned about it, and realized, oh yeah, it opens up all those other things as well. Then maybe they're not the things I necessarily want to build. I absolutely want them to exist for the world though. But having my piece of something that like or like Harry and I's piece that we wanted to build was the really clear moment where we're like, okay, right, now we get the full stack. We also get why all the other pieces exist. We believe in them. And it's something we use heavily now in hiring where we know we're going to interview people on like machine learning roles who are in that state we were in before we had that realization. So it's like, I know you probably philosophically agree with this, but you haven't had that like missing piece yet. And we try and give people that missing piece so that they can kind of realize the same realization we did a few years ago.
Yeah. It's a real it's like awakening, a consciousness shift, like a transformation in how we operate in our brains. Where in the old world, we're seeking permission from outside of ourselves. And then now you're like, wait a minute, I don't need to seek permission. I have the tools to do this of my own volition. And I think that just fundamentally resets humanity at large, at scale. And it's like the greatest thing ever. Okay.
Yep, totally.
So Jensen. Um, Jensen, when I was going into this conversation with you and having to sort of really, really go deep and really understand, I knew what it was theoretically. I'm like, yeah, yeah, yeah. Then I really understood the scale at which you're operating. And I was just like, holy crap, that is massive. Like, this is not, you're not just a two-sided marketplace for compute. You're like a layer across the planet, a layer across everything. Tell us about how now that you got the compute layer, I mean, sorry, the protocol, the blockchain component, now how does your thinking expand and how does Jensen now become Jensen? Like, tell us about how that happened and then
Yeah.
what you're actually building. And then I want you to talk about how that compares to a decentralized tech stack, AI tech stack versus the centralized AI tech stack, and how a developer functioning in these two different worlds would operate. Okay, go.
Got it. Yeah. So the cleanest thing that I guess you can describe as building in the first instance is that immediate programmatic access to theoretically any compute device in the world. So you say the kind of mindset shift to take it from the sort of customer, as it were, or the eventual downstream customer all the way at the kind of bottom is somebody needs some operations to happen, some machine learning operations. Maybe that's just the forward pass through a neural network. Maybe it's forward and backward pass, whatever. It's a set of mathematical operations. They need that to happen. And right now, for that to happen, there's this long chain of stuff that other people in the world need to do before they can just connect to this compute device and make it happen. There'll be companies in the way. So, like if you think of it as a pure consumer, you're probably using a company who's developed a model. That company's like using some compute and some data from somebody else, and that person's providing the compute in a data center, and then they had to buy compute from somebody, et cetera, et cetera. You've got this long kind of chain all the way up. This is a little bit like what happened in the cloud market, where originally it was like you had a need for a business to have the ability to execute operations somewhere, and they'd have to like build a data center and buy hardware and put it in and have like engineers build the thing. And then like cloud came along and said, hey, actually we can abstract all that. You just need to like do your operations somewhere. You can get a virtual machine and you can do it direct on this virtual machine. And then another shift happened within like application development where it said, as an application developer right now, you still have to go and like SSH into this virtual machine somewhere and set it up and understand how all that works. You don't need to do that. It can be serverless. All you need to do is write your application and you push it out and it's going to execute, and we'll deal with how it executes. And so we think the exact same shift can happen for machine learning, where machine learning engineers, researchers, developers, etc., right now have to think a lot about where and how their task is executing, but they shouldn't necessarily have to think about that. Compute itself is just the ability to execute the operations, but right now you have to think about which device is capable of doing that. What size is my model? Does it fit on that device? Can I split it across devices? You have to basically become this distributed systems engineer in order to do it, and we don't think that's necessary. We think that can all be done programmatically if you can unlock the landscape of compute to allow somebody to do it. So what we'd like to see is this shift in the mindset of a machine learning developer or researcher where they don't think about the compute anymore. What they think about is, hey, I've designed this new model. I've got some data from somewhere. I just need to train it. Like I need it to do 100,000 operations. Go. And they can just hit go and it just goes somewhere. Maybe it happens partly on their local machine, maybe entirely. Maybe it happens partly on cloud, entirely on cloud. Maybe it happens on a random other person's MacBook. Like it doesn't necessarily matter technically. It matters in the current world because of like trust, basically. Because if I wanted to run operations on your MacBook, we would have to have some agreement. We'd have to sign something together. I'd have to figure out a way to pay you, to trust you. I could sue you if you didn't do them, but it's going to have to go through the human world. None of that needs to exist anymore with the technology that we have. You can do all of it programmatically, but somebody has to build that. And it's actually turns out pretty hard to build. So we kind of set out on that path to say, right, let's move the world from all of this kind of human world steps in order to do that execution to all programmatic.
So smart contracts.
Yes. It's basically saying, put the whole thing in a smart contract. The thing is, there's obviously a lot more technical detail to that that makes it significantly harder. But in essence, it is that. It's put my machine learning execution in a smart contract, and then I can pay you, I can trust you, you can do the work, you get paid, all good.
Brilliant. And so how long have you been working on this now? Once you come to the realization and you found the blockchain, how long have you been working on actual Gensyn?
Yeah, so probably about 4 years now, or maybe three to 4 years, depending on when you kind of when you think about the start point. And I think we've gone through probably 3 phases in that time. The first phase was almost entirely research. It was basically pure research. It was saying, can you actually solve this trust problem full stop? Like, can I establish trust over machine learning execution? It's massive, it's non-deterministic, it's state dependent, it's this really weird thing to do. Maybe you actually can't even solve it. We thought you could. A lot of the world, most of the world, frankly, thought you couldn't. So the first phase was us just going deep and figuring out the research. We came out with our light paper, which was the first proposal for how to do that. Incidentally, I think a bunch of teams have actually built very similar things to that light paper with those principles since then, which is interesting. But what we kind of realized at that point is we moved into the next phase, which was, this is a reasonable proposal, but there's a lot of things in it that could be made better. And so we spent another like chunk of time, probably 12 plus months, making that better from a research perspective. So a lot of that was identification of cryptographic proofs as definitely a key part of the system. There's lots of flaws if you don't have that. You can try and hide those flaws away, but they exist and they will come out when you get to any kind of scale. But also efficiency pieces of like the certain pieces of it that would have just been too inefficient, but you can make them more efficient with a bit of like game theoretic research, etc. So it was another period of research there. And then the final period, or kind of the period that's, I guess, just ended for us was, okay, this is good from a research perspective, but it's really hard to build. So you need a bunch of engineers. You need to do GPU engineering, compiler engineering, protocol engineering, distributed systems engineering, etc. You need to build a team to be able to do this. And so we went out and did that, and we raised a round. That was our Series A to say, right, we need to build the team. We need to start building the fundamental tech. And that brings us to now, which is a kind of another phase change where we've built a lot of that tech now. We have our own compiler, we have our own reproducibility libraries, we can do deterministic execution, etc. Now is the time to then build that into the products that people can use. So the thing that does the sort of minimum viable version of what we've described this whole time of doing that outsourced execution, handling trust, handling payments, etc., and being that kind of base layer. Initially, obviously, that's going to be reasonably bare bones in certain ways. We have to iterate and kind of
Yeah.
learn from the way people interact with it. But that's the kind of next phase of Gensyn that's coming up. But yeah, those have been the kind of major sort of, I guess, phases of this so far.
So at this point in January, end of January 2025, who can use Gensyn? Can anyone use it? Can developers use Gensyn now?
Not quite yet.
Okay.
If you talk to us, and we've said this for a long time, but if you talk to us, we can probably trial some things. But
Yeah.
we generally we're not kind of public live yet.
Yeah.
It won't be too long, a few months before we have something that everyone
Right.
can interact with. But for now, we've been focused on those deeper libraries, like the reproducibility library, the compiler, etc. But very soon you'll be able to actually like execute some stuff. And we're very keen to talk to people, as we always have been, on both the supply side. So if you have hardware and you want to connect it up, whether that's data center grade or even consumer grade, and whether or not you want to execute machine learning with those trust guarantees. Our view is long term, all machine learning should be executed in this way because it's the lowest cost, highest scale way you can possibly do it for the world globally. But before we get to that stage, there are certain use cases which are particularly interesting to the world before we kind of get that larger scale adoption. Some of those are doing very large scale decentralized training runs, for example. There's a few companies that are doing these. We're pretty close to them that do communication efficient methods for connecting up lots of like distributed compute. Obviously, we can provide that compute and we can
Mm.
provide it trusted as well because we can do
Yeah.
verification. You've also got the use cases where people really want to be able to prove the execution of an AI model on chain. So if it's going to do some financial transactions, if it needs to be completely transparent, a lot of the agents that you see operating kind of on Twitter and sort of in the financial markets right now, there's a lot of smoke and mirrors behind those. There is a
Mm-hmm.
human in the loop who is
Mm-hmm.
translating that to what actually comes out to the world. With Gensyn, that human doesn't need to be there. The entire thing can be transparent. You can have it execute and trace it through a chain to say, I know exactly what happened here. It is the pure execution of this model, and I can prove that. And we think that really changes the dynamic of our interactions with those agents. It makes them just far more transparent than they currently are, and sort of takes away those smoke and mirrors that you
Yeah.
see in a lot of them at the moment.
Yep. Um, okay, so looking at the centralized AI tech stack versus the decentralized AI tech stack. Tell us just in layman's terms what those two are and why the one that you're building in is different and how it works. And how what Gensyn the role Gensyn plays in the DAI tech stack.
Sure. So I guess the centralized AI tech stack has grown around vertical scaling predominantly. So if you look at the kind of history of it, and it says that we realized that we could take these mathematical operations and execute them at a speed which was viable in the real world on GPUs. We quite quickly realized that increasing the size of the neural network itself increases its efficacy if you have enough data. And so then you kind of saturate the GPU and you say, right, well, I've filled the memory and I've made the biggest model I can. It's more effective, but can I go bigger? That goes in two paths. One is offloading, where you just split the model in half, you do half of it, and then you swap it out and you do the other half, and you kind of do it that way on a single device. And that works, but it's very slow because you're limited by how many times you split it. It's pure serial execution and you're swapping the model off and on. So then you go to, can I just put two GPUs next to each other? They each do half, and then I get a model that's twice the size. Yes, I can do that. That's effective. I'm skipping a load of things here in how you shard a model up, and there's other techniques you can use, data parallelism and things, but I'll skip that for now,
Yeah.
just on the scaling piece.
Yeah.
Companies ran with that to make better models, principally OpenAI, who had kind of all of their eggs behind scaling is the most effective thing that we can do. Ilya Sutskever had the position of scaling is essentially all that matters. And so they put resources behind it and said, we're just going to go all out on scaling. And they did that. So they took the fastest, most kind of obvious way that you could scale a machine learning model, which in similar way to distributed systems, vertical scaling is just the kind of fastest thing you can do. It hides a lot of the problems you would get from adding a load of other devices in and dealing with connectivity, and basically just says everything's like in one place and kind of connected up really fast, and it can just kind of get bigger in that way. Again, hiding loads of details, but that was the approach, and that showed us that machine learning could do some amazing things. It got us GPT, and then it got us Chat GPT, which is most of the world's interface to the GPT models. And then it got us Llama, etc. It got us all of these really exciting models, and it proved to the world that ML as a technology was enormously transformational outside of the technical people who'd been kind of tinkering with it in certain areas.
Yeah.
And at the same time, we got the emergence of foundation models with kind of emergent logic and things, which was incredible. So that's the centralized world up until now, and you still see this focus on vertical scaling, although it is shifting now because of, interestingly, kind of like physical world constraints. So putting enough GPUs in a single data center to actually keep scaling these models gets beyond, hey, can we pay for it? Like you look at like Meta and you say, of course they can pay for it if they want to. Like they essentially have unlimited funds, so they can do it. But actually, can we cool this thing? Like, is it even physically
Can we
possible
cool
to
it?
cool?
Yeah.
Do we have the space, the physical space to put this many GPUs in like one location? Can we get electricity to it? Like you start getting above 2 gigawatt data centers, and you say, well, we need enough power to power a city to go into this thing. If we keep scaling that up, we have to get power into one place, and so we start stressing physical limits, basically. And so our view on that is centralized kind of vertical scaling was our quick way as humanity to prove that these techniques work. But you look at the kind of normal technical world and distributed systems, and that's typically what you do. You scale vertically until a certain point when you get diminishing returns, and then you scale horizontally. And to us, the only way to scale horizontally is to do this decentralization piece. It's to solve the trust problem and then take off the scaling limits and scale to whatever compute the world has. You're seeing these centralized companies right now scale horizontally to an extent. So they'll go into data center and they'll get 2 data centers and they'll connect them together, and then they can go a bit bigger. And we look at that and we say, okay, yeah, sure, they can do that. They're going to fight each other, but they're going to get scaling limits with the number of data centers they have. Maybe they can collaborate, but they're still going to hit limits. Yeah. If we want to take the limiters off, we need a way to be able to connect to every device. And the techniques they use to go into data center, they can come over to the every device case. They won't quite be as performant, but they'll work. But we can have new techniques that do the every device case. But the crucial piece is there has to be infrastructure that connects them together. Otherwise, you can't do it. Yeah. So it's acknowledging that our belief is you can build machine learning models and communication methods that allow them to be built over highly distributed, decentralized devices. But in order to actually do that, you've got to have the infrastructure rails to actually talk between them, establish trust, manage payments and attribution, and all the rest of it. And that's what Gensyn builds. We build that infrastructure to allow the rest to kind of exist on top.
Love it. Okay, so it's 2030, Ben. What's happening? Let's talk about what's the future. It's so funny. People talk about AI and, oh my God, look at what this one's doing and that's one doing. And OpenAI dropped Operator yesterday and blah, 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 and Davos and this and that and Claude. And they're all going on and on and on. And I'm looking at them and thinking, you guys have no idea what's coming. We're going to disrupt you completely. The future of AI is not what your future of AI is. So let's talk about, Ben. Let's talk about the real future of AI. It's 2030. Your vision of how this whole thing operates and how you're building that new future, that real future, that possibility that we would all like to see versus what's happening right now.
Sure. So I'll do this from maybe 2 directions. One is the kind of like the whole world's direction, so that the way the world experiences AI, and then I can do it from like the infrastructure direction and the way it kind of grows up from there. Yeah. So starting out, the way the world experiences AI, I think there's lots of stuff being thrown around about how like AI agents will change the way we kind of work in the world, and maybe I will send out my own AI agents and they'll operate within the kind of world and they'll use the things that I use. They'll phone up businesses and things like that, and they'll act as humans. Broadly, I struggle with that anthropomorphization because I see it as a convenient kind of like truth for people to jump to in the face of uncertainty. It's a typical thing that humans do, right? Like we anthropomorphize things we don't understand.
Yeah.
We create like human style visions of things to be able to actually get our heads around them. I don't think that's how necessarily machine learning is going to progress. I think we will have bits of that, and I think there'll be kind of things acting on our behalf, but I don't necessarily think they'll be as anthropomorphized as we say they will be. What
Mm,
I do know is the base way that we as humans interact with technology and kind of knowledge itself is going to change and go through a lens. And that lens is going to be machine learning. The way I think this presents itself to people is in a change to the way we think about technology itself, where for a long time, or for the whole period of kind of computing, we've known computers as these devices that we have to deterministically interact with. So I give a computer an instruction and it executes exactly that instruction. And like programming, for example, is exactly this. I have to say, imperatively, this is exactly what you're going to do, and you're going to execute it. And I have to think and sit there and think of all the edge cases and say, this is what should happen in this situation, in this situation, in this situation. Essentially, what I'm doing is creating an expert system. I'm taking my view of how this kind of world works and I'm putting it onto the machine. But it requires enormous effort from me to tell the machine how to act in all these different situations. I think that deterministic approach was required because of the way things worked, but it's not necessarily that natural for humans. When we
right.
interact with each other, we interact incredibly probabilistically. We
Yeah.
don't even think about it too much, but in our brains, we're constantly calculating probabilities and deciding what we think is going to happen in every interaction, in our interaction with the environment. We're always thinking like this. And I think the change that will happen with machine learning is that technology, knowledge, specific like electrical devices start to become more probabilistic to us. So we start interacting with them as we do with humans, as we do with the environment in a way where we expect it to be probabilistic. So we're going to have to shift from I can trust everything that this like device does because I know it's coded exactly to take this set of steps to it will act within this environment based on some kind of like brief it has, but that brief can be represented in human terms. So we can kind of understand in the same way if a human tells us, hey, in this situation, I typically do X, a machine can do the same. And we can know, okay, I'm going to put some error bars on that. I don't know exactly what's going to
Yeah.
happen, but that's fine. I deal with humans every day. I know that that's the case. I think we're going to have that shift with technology. But when we do that, we take away an enormous mental lift that we're constantly having to do to basically do the almost like analog digital conversion in our heads. We're all doing that. We're all DAX basically, which is crazy. We don't necessarily have to do that. We're shifting that conversion burden to the machine. It needs to tell us how it's doing it. But from there, we're freed up to do much more of the probabilistic stuff. And so what I think it does is it kind of changes this human computer relationship from being heavily on the effort of the human side to heavily on the electricity side. Long story short, that lets us essentially augment human knowledge work by increasing electricity inputs rather than biological inputs. So you say a human, and this is probably reasonably indisputable, if you say in most knowledge situations, a human plus a computer is better than a human solo. So it augments our abilities, it makes us more effective. To scale that right now, we basically just have to like add more humans, which is ridiculously expensive. Like creating another human is a very difficult thing to do. It takes a very long time. It takes a lot of energy from a human perspective, but that's how we kind of increase that.
Hmm.
Or they get slightly better at using computers. But in this new world, we say to make this pair more effective, actually, if we just put more electricity in, we beef up this machine, this human machine interaction gets better, and we can keep scaling that. We don't know how far we can go, but we're going to augment every human by putting electricity in. And so I think that's like absolutely kind of fascinating as a just experimental line because
Yeah.
like where can it go? What is the ceiling? Nobody knows, and that's why everyone's kind of throwing in suggestions of how that happens and things. But yeah, at the low level, I think it scales up how effective a human is at any interaction with like data, knowledge, etc.
Oh, beautifully said. Okay, we're going to take some questions. Folks, if you want to have a question for Ben, please show yourself and ask your question. I think it's going to take a second for people to pop on. Um, I really like that last way you said it. Like, that's really what's happening. Like, the machine machines are going to make humans amplify humanity in that sense, rather than be something that detracts from humanity. I really like that perspective. Okay,
I
so
think we've just on that we've got
yeah,
precedent for that as well, where I think there's always these fears with every new technology, right? Of like, how is this going to disrupt things? It's going to
yeah.
result in change. That can be quite scary, and we've seen that before. The cleanest example, I think, is the disputes from the 2010s around how it changes radiologists. So we had these computer vision models which could assess like X-rays, and they could find out the bad things in an X-ray, and they could potentially diagnose from that X-ray. And a lot
Right.
of people said, "Hey, this is going to make radiologists obsolete. We're going to lose a load of jobs. What are those humans going to do, etc." That's not what happened in reality. What happened in reality is being a radiologist it became different. Instead of you having to look at every X-ray and point out every single thing within it, you looked at an X-ray that was annotated, and it would just hint, and it would say, "Hey, look at this area. This looks suspicious." And you, as a radiologist, were actually using your expertise a larger percentage of the time than the situations where, I don't know, there's a super obvious break in it, and you have to go and you have to do all of the work. In that situation, that would already be pre-annotated. You would still do the decision making, but you're doing the expert piece rather than all of the kind of work itself. We think the same thing happens in basically every area. It doesn't make humans obsolete. It just moves the work that humans are doing to be more specific, more niche, more expert. And we should be spending a larger percentage of our time on that work because it's higher impact. So
Doing the creative,
it's
fun stuff.
yeah,
Ben,
exactly.
Ben, if we
Yeah.
went over a few minutes, would you be okay with that? Do you have like
Uh,
10 extra minutes? Or you do have a hard
yes,
stop?
I can do 10 minutes, but I
Okay.
have to jump in the car to get
Yeah,
to
yeah.
an
Okay,
in-person
good.
meeting,
All right.
unfortunately.
Because we've been going. I want to make sure people get their questions in. Okay, who
Cool.
wants to go first with their question? McCain.
Um, so I'll just jump in. Humans are notoriously bad at probability. And so when you're talking about machine learning and helping us be better at probability, I don't know that that's actually possible. From a behavioral standpoint in economics, like humans, we're the worst, actually. We think we're the best, but we're the worst, especially with probabilities. And I'm just wondering how, when you pair machine learning with this data and this massive amount of information, and then you pair it with the flaws in our thinking, like how many new conspiracy theories are going to like be able to be formed because of this type of access? So it's one of those, like, I want to know where these breakdowns happen. Like, how are we going to prevent these breakdowns on the human side after we have all this information?
That's a really good question. And I totally agree. I think you look at a human's ability to sort of calculate like tail distributions and things, and it's completely skewed. Like we are, like you say, absolutely terrible at it. What I think happens is it's almost like the 80%, 20% piece. Like in having machine learning work in a probabilistic way, it frees up enormous amounts of the deterministic kind of calculation work we would have had to do otherwise. But as you described, there are going to be tail cases where we're still going to want determinism. We need to know. We need to be able to kind of trust a machine to give us like a deterministic output that says, okay, this is the situation. There's no kind of like misconceptions in there. This set of steps has executed, and this is what you know. And a great example of that is within the kind of crypto rails themselves. They have to be deterministic. So you have to put these kind of guardrails of determinism in to do the operations that we do know need to be executed in that way so that we can have that like 80% increase on the probabilistic side. But maybe I've described it in like kind of too holistic way. Like it can't all be probabilities as you've described, because I think humans then, yeah, become kind of embroiled in the tails and highly upweight the very low probability things of happening and like downweight the high probability things and things like that. So there's definitely guardrails and deterministic pieces. The crypto piece is a great example. There are probably others. But I think broadly my stance is optimistic that we can handle those as a society versus holding us back necessarily and not kind of leaning into a technology like this, which I think would actually be worse because we already struggle with those kind of edge cases and those probabilities, like you say with the conspiracy theories. I do think, incidentally, there's a new wave of not conspiracy theory, but there's a new wave of like human belief coming, which is a religion around AI. I think we're in the anthropomorphization we're going to do that on top of AI. There's some strong arguments that could be made that you could also invalidate, that AI is the instantiation of God. If you claim that God is a construction of human beliefs, people are going to claim that. People are going to claim to then be the prophets of that. And we're going to see a huge kind of like religious movement around that. I'm somewhat worried about how that's going to present itself, but I'm almost certain it is going to happen. So we'll all need to look forward to that.
Yeah, well, okay, who wants to go next? Maroon, unmute.
Unmute. Okay. Hello, I want to ask you two questions. First of all, you are saying that you are making a decentralized model. So how can we make the compatibility between a decentralized model and at the same time the privacy for a user? And the second question is how you will handle, for example, the development of quantum computing, the 51% problem. Is it quantum proof or not, your protocol?
Great questions. So on the first one, the privacy problem, I think privacy is highly use case dependent. And so you have to really drill down into what's happening in each instance. Where is data going? Where is it being used? What's it being used for? And is information extractable from its use? And those are hard problems. We do have a set of technologies which can help us solve each of those problems. So you can do outsourced execution of machine learning computation in a way that is hidden from the person doing the computation. So for example, you can do encrypted machine learning execution. It's very expensive, but it's possible with functional encryption, with fully homomorphic encryption. Again, super expensive. Functional encryption's probably reasonably applicable from an engineering perspective now. Fully homomorphic is probably still research, to be honest. Like, I don't think anyone would actually apply it in anger. But you've also got multi-party computation, where you shard a machine learning model and it can be completely obfuscated. The only way to actually introspect it and introspect on the data would be to gather together 6+ shards from different people and kind of combine them. All of that can be wrapped up in a game theoretic incentive. So it actually becomes financially unviable to collect all of those shards together. So there's many techniques, there's more differential privacy, etc. There's more that you can use, but you can apply privacy in a remote context. But you can't just blanket apply that. You can't just say to everyone, hey, the entire kind of Gensyn execution is multi-party computation or fully homomorphic, because it's too expensive for so many use cases. So what you have to do is drill down into the use case and say, where's the data going? Is the user okay with the data from this location going to this location? If they are, then that can happen. If they're not, then we need to jump to another technique. Actually, what I think happens then is computation goes locally most of the time. It's the lowest cost, most kind of effective way of doing it. Sometimes they'll send the data. At that point, you'll have that like remote multi-party computation, homomorphic encryption, but it's more expensive. So you have to pick the approach that you need to take in each situation. Our goal is basically to hand that to the market. So we say we've built the rails for the execution to happen anywhere. We've crucially designed those rails that they allow all of those privacy techniques to happen. There's shortcuts we could have made in the design of Gensyn, which would have stopped fully homomorphic encryption from working, etc. So you can use kind of heuristics on a training process to verify the work. It doesn't, it verifies something else, but in doing that, it stops you from being able to do encrypted machine learning. So we've designed it in a way that the rails exist. You can do the execution anywhere. The way you do it, whether it's encrypted, whether it's sharded, whether it's differentially private, is up to you. And then we let the market decide for each use case, do I need it to be differentially private for this use case? And I'll pay more for that. Do I need it to be fully homomorphic? I'll pay a lot more for that because I'm going to do loads more computation. But for my use case, maybe actually I do want that. Like, it has to be. And so from our perspective, that can't be decided by any company that hasn't gone out and basically tested the market and made the decisions of, is my cost basis right for the kind of value of the thing that I'm doing out in the world? That shouldn't be done by one company. That should be done by a whole ecosystem of companies, is our view. We just give them the tools to do it. Your second point on the quantum resistance, This is a bit of an existential question for, I think, the entire blockchain space. It's very hard to get kind of answers on how we can mitigate that. You get quantum resistant hashing and things like that, but they only address the most obvious ways that quantum is going to affect encryption. They kind of address the ways that we can see right now how it would change the world. There are a bunch of ways that we can't see, the known unknowns or the unknown unknowns, sorry, where we just don't know what's going to happen. So yes, you can be quantum resistant, but at the end of the day, I don't think that's the huge step to say that we're insulated. I don't think anyone is realistically insulated because we're not sure how it's going to instantiate itself. What I do know is it's still a pretty long time away. We get breakthroughs periodically. Quantum's always been in this case like for a decade plus, where every few years there'll be some breakthrough. That breakthrough gets kind of bubbles up in the news. It's important that that happens because it pushes funding to quantum to keep us doing it. But realistically, none of those breakthroughs are close to actual real world viability. They're still all research breakthroughs. So we're a while away still. It's important that we keep talking about it because it keeps funding going to it. But what's going to happen is relatively unknown. One of the things we do know for Gensyn is if when quantum comes to machine learning execution, which we think it will, it introduces another layer of non-determinism, which we have to deal with. And that's something we think about. So making sure that our verification system isn't holistic, like wholly dependent on determinism is something we care about, because native execution in a quantum environment just is not deterministic. It's going to be stochastic. So we have to have a conversion from that. But yeah, we think about it mostly from the ML side, not necessarily from the encryption side, just because we think the knock-on effects of that are going to be huge. No one really knows the details yet. They've just done the kind of basic mitigations. We use the tools that do those mitigations, same as everybody else does. We're just not kind of going to say, hey, yep, that's all the work done, it's going to be fine. We think it's going to be still a bit rocky, but probably 10 plus years out.
Yeah. Any more questions for Jamie Workman? Go for it, Jamie.
Ben, this is great, but you'd said like you want to give companies or users the tools to do X that they need to do with machine learning. And my question is, how user-friendly have you designed it to be? Like, I don't code, I don't have a computer science degree. Do I need to find a developer that then talks to your developers to use these tools? Or is it going to be, or already may be, I don't know, able for me to do it, like a chat GPT type thing. It's like, hey, I want you to take this data set with all these utilities, calculate this, use column B or something like that.
Yeah, that's a great question for a company like us, because we are building infrastructure. We long-term build for the companies that build the tools that the individual will interact with. So we build an ecosystem where people can interact with our technology, but we don't necessarily build all the way to the consumer, because the challenges in that are very different to the challenges in building infrastructure. There's also crucially competitive advantages within kind of the way you build the infrastructure. And what we want, kind of rolling back up to earlier in this call, is to create the most kind of fluid, competitive landscape we can, because that leads to the best outcomes for the world. So us also doing the full stack actually is us doing what the kind of centralized companies we've sort of accused of creating monopolies are doing, right? Like they're trying to capture the entire thing, which isn't necessarily the best thing to happen. Counterpart to that is you can't just build infrastructure and then just like unveil it to the world and be like, hey, everyone use this now, because absolutely no one knows what you're supposed to do with it or how it works. So we have to kind of tread this path of, we will build things that go much closer to the consumer in the early days. We view them internally as demonstrations. So we'll build these applications. They're not intended to be super competitive with everybody else. They're just intended to give you something you can interact with, which shows behind the scenes it uses all of these kind of value benefits of the infrastructure we've built. But what we want to happen after that is somebody looks at it and says, you know what, I can build a better version of that. And they do. And then that keeps happening. And in the end, we get out-competed on our demos very quickly. And we end up with this ecosystem of companies that have built the kind of like user-facing apps on top of us. We start to fade into the background as infrastructure, a lot like TCP/IP has. Most people don't think about it, but they're using it. Everyone's using it, but you're not using it directly. You're using it through all these kind of like competitive interfaces that people have built on top of it for other reasons. So long term, people won't think about us other than developers themselves. Short term, we have to build demos that like zag all the way through the stack just to show what's possible, but we want to be out-competed on them quite quickly.
Anyone else? Questions? Questions
This
for
is Rich.
Ben?
I did have a
Yes,
question
Rich.
if time permits.
Yes, time permits.
I was curious to get a better understanding, Ben, how Gensyn would position itself or differentiate from the current generation of deep-in compute providers, companies, or services like Akash or Ether or those.
Yeah, great question. So interestingly, we've been around for not longer than all of them, but longer than a good bunch of these companies. And the one thing that we've always kept true is that we believe that this should be entirely programmatic as an infrastructure. And so we want to solve the hard problems that stop it from being programmatic. There are things you can do to go halfway, as it were. So you look at the current situation, you say right now, somebody's going to go and book time on an AWS GPU in order to run their machine learning models. They could be booking time on a decentralized GPU somewhere in the world. And all I need to do as a company is kind of make that connection happen. I just need to collect all these like random GPUs in the world up and give them access to book time on them. In our view, that's an optimization on the current market. It increases the supply if you can connect up those decentralized devices, but that's all it does. The centralized companies compete with that, so they just like lower prices. They can go pretty low. They can get their margins very, very thin, and you end up in this kind of bidding war where your only defensibility against them is like maybe you have a slightly increased decentralized supply, but they have economies of scale. We look at that and we say, okay, we think a bigger change needs to happen. The real opportunity here is changing the entire dynamics of this market. You shouldn't be booking time on a specific named GPU because you as a person who wants to run machine learning operations doesn't care about that. What you care about is the efficiency trade-off of how quickly your operations happen and how much you pay for them. And so what we want to do is create that abstraction that says, forget the GPUs. You don't even need to care where they are, what they are, who's running them or anything like that. You don't need time on them because time is a proxy for what you actually care about, which is just doing your operations. You've got a million operations that you want to perform. You have to go through this mental kind of arithmetic to say on an NVIDIA H100, that should take like an hour and 20 minutes. Therefore, I'll have to book 2 hours on this GPU in order to get it done in time. And if it doesn't, it's on me. Forget that. You push a million operations, they happen, you pay for it. That's what you care about. And so Gensyn goes direct for that goal and says, let's change this whole market. Let's change the way people think about compute rather than an optimization on the current kind of centralized AWS landscape where you have an interface that basically looks the same, but behind the scenes, like the supply has changed a little bit. So we've always been very deliberate about that. It's why we haven't shipped an interface like that, because we could have quickly done that and done the tech behind the scenes. We think when you do that, you build a company that indexes towards maintaining that interface. You don't build a company that can build the real tech. So we're very kind of focused on that long-term build that tech. It means it looks like we move slower, but in our opinion, we build the tech that actually creates that new market rather than the tech that gets captured within the kind of efficiencies of the current market. That being said, look at a business like Akash. I know Greg very well. I think what Akash has done is very good. I think they've created a marketing push which shows that it's viable to do this in a decentralized way. And I think they've gone down a path of saying, you know what, verification for us doesn't necessarily matter. Like we're just going to make the connection between people with GPUs or CPUs or whatever. I think that's a good play. And I think that does have a space in the world. But like I said, to me, that's like a percentage optimization on the current market. It's not a new market. And we're aiming for that new market.
And creating a new market. Ben, thanks everyone. We're going to wrap up. Ben, I know we have like 2-3 minutes, so very quickly. What's your advice? You found that you became this founder and this innovator and this person who's building the future. What's your advice? I think way more people, as we move forward into this very different world, way more people are going to have to become innovators and founders themselves. I'd like to see every single domain expert utilize these new machines and become founders and innovators themselves. What's your advice for them? Quickly, 2 or 3 things that you learned on your journey that you're like, this is what you need to know.
So probably biggest thing is everybody has far more agency than they think. Most people don't like to, but they by default put themselves in a box because it's easier for us to understand as humans. So we try and put in the parameters of what we think is possible for us. We put those around ourselves and then we operate within those parameters. So we say, hey, can I do something? And then you look at the outside world and you say, well, there's this blocker, there's this blocker, there's this blocker. No, I can't do that. I'll have to do something else. And I think most of the time that's false. We construct a false view of that. This goes back to what McKean said around our ability to estimate probabilities, right? Like we're just bad at that. And so we don't see these opportunities. So one of the biggest things I would say to people is don't artificially limit yourself. And the clearest way of doing this is to have a layer of introspection every time you do that. So when you think about, can I do something? I want something to happen. Can I do X? If you start listing reasons why you think you can't do X, deeply think about whether those reasons hold or whether they're kind of convenient to you. A lot of the time, probably two things are happening. One, you don't want them necessarily to be open because that scares you, because you're going to have to do an action that actually is quite scary. So there's a fear piece. The second piece is you're actually just putting higher probabilities on those blockers than exist in the world, and doing that introspection to say, have I valued this blocker correctly? And does it actually exist? Or do I just kind of want it to exist because it gives me an excuse not to do the thing that scares me? And if you go through that process, you'll probably find that most of those blockers don't actually exist. Once you have established those blockers, next thing to do is to go directly at the blocker itself. So instead of doing the thing that we typically like to do as humans, which is the comfortable approach of saying, right, I think I can do this thing. Let's go and test the bits that I'm excited about and I think will work. Don't test those. They're the bits that you don't need to think about too much. Go and test the bits that you think this won't work, the thing that will stop this from happening. Run directly at that. This is something that the accelerator that Harry and I met on pushes really hard, and they describe it as running into the spikes on any idea. What you want to do is have the mindset of invalidating your idea as fast as possible rather than validating it. Humans like to validate things, but that's not necessarily useful. What's useful is invalidating. So try and invalidate it. What you'll end up out of the end is you'll have invalidated a load of things, and you'll have something that no matter how much you try to invalidate, it'll still exist. That's the thing that's viable, and that's what you should be doing, because you've tried your hardest at proving that it cannot exist. And then that's put it through a real test. Particularly in the startup world, this is very important because that's exactly what any venture capitalist is going to do immediately upon you talking to them. And the strongest way you can show up to that meeting is having been through the thought process they're going to take you through in the meeting. They're going to try and invalidate it. And in doing it, if you've already tried to do it, you're going to have an answer to every single thing they come up with, unless for some reason you've missed something, which you shouldn't have done because you know your area better than they do. So biggest thing, invalidate and trust in your own agency. You have far more than you think you do.
That's beautiful. Okay, I know you have to go, but what's next for Gensyn, you and Gensyn, and how can people get involved?
Sure. Next big step for us is the launch, when we launch out the first version of our technology, our testnet in the crypto world, but our just kind of tech existing and providing access to compute in the kind of machine learning world. That'll be happening over the next few months. And obviously we would love people to come and try it, both from a demand side, so wanting access to compute, but also from a supply side, if you have compute and you want to just run something on your machine and be executing tasks for somebody else somewhere out in the world, we need both of those kind of profiles of people to interact with us. We'll put more information out in the kind of demos that I described. So it won't just be pure infrastructure for like really deeply technical people. It'll be all the way up to the kind of demonstrations. So there'll be things that everyone can interact with. They'll look a bit like what you see out in the world, like some of the agent stuff and like interaction with language models, but also like joining a training run, for example, and being part of a larger scale, more distributed creation of a machine learning model. Like a lot of people can be involved in that. You don't have to be a machine learning expert in those demos. And we'd like to get people in because it stress tests our technology. From there, obviously, we want the people who are building the technologies as well. So we want the people doing those training runs. We want the people designing the agents, the language models, etc., to come and design them on Gensyn with us so we can shape the technology around them. And the big value proposition from us is you get access to cheaper compute, far higher scale compute, and crucially trustworthy execution. So you can have this transparent, trusted execution of your machine learning model in the crypto sense, completely on chain. You'll be able to call the execution from an on-chain contract. You'll be able to trust it in the contract like an oracle to the execution of the machine learning model, which is, in our view, sorely missing in that kind of agent infrastructure right now. So all of these things start getting unlocked, but the first instance is just use the stuff we put out, give us feedback, and get in touch if you want to kind of get involved even sooner. chances are we might have something you can run or you can interact with before the public releases go out.
Well, we would definitely want to have you back closer to the launch and perhaps create a whole sort of something around it, because I think this is the coolest thing ever. Ben, thank you so much. This was amazing. Thanks for sticking around longer. And yeah, I'm looking forward to seeing how this unfolds.
Likewise. Thank you so much, Misha. Really enjoyed this. Thanks everyone for your questions as well. If you have any further questions for me, feel free to ping me. I may be slow to reply. I get a lot of messages, but broadly, just pester me if you really want an answer and you want to chat to me, and I'll eventually get back to you. It's not personal, it's volume based, but always love chatting to people about these topics.
And the best way for anyone to reach you is Twitter or DMs, or what's your best way? Yeah, that's good.
Twitter DMs is probably the best way.
Okay,
yeah.
Cool, wonderful. Thank you, Ben. Have a great rest of your evening. It's kind of late there, right?
Thank you. I'm in LA, so it's.
Oh, you're in LA.
morning.
I'm in. Yeah. It's ash, smoke. It's been. Anyway, okay. Well, thanks so much. Take care, Ben.
Thank you. You too. Bye.
If you're serious about being part of the future, join us at Innoveum. We're a community where innovators, creators, and pioneers come together to learn, collaborate, and launch new things. Get access to exclusive workshops, live events, and meet world-class founders. Join today at innovium.xyz. The future won't wait. Neither should you.